In this demonstration, I want to showcase how easy it is to use NASTRAN Solution 200 with the use of this web app. What this web app does is the following. If you have a NASTRAN 100 PDF file, the web app will help you convert it to NASTRAN Solution 200. It will help you create your design variables, your objective, and your constraints. And to show you what the process is like, I'm going to use the familiar 3-bar truss example that's inside of the NASTRAN optimization manual. And like most users, you may have already created the model in your pre-post processor. You might have a BDF or DAT file. Here we're performing a solution 101 or linear statics analysis. And this is where a typical user will start off with. Let me select all of the text and copy it, and then place it in the web app. The web app will then go ahead and identify all the parameters that can be set as design variables. I can set the areas of the rods as design variables. The material Young's modulus, Poisson ratio, and density are all parameters I can set as design variables. I'll go ahead and select the 3 areas as design variables. So we'll go ahead and select area 1, 2, and 3. Here in the next table, my design variables are created for me. I can go ahead and type in the bounds for the lower and the upper. So let me go ahead and do that. And you'll notice that as I interact with the web app, on the right, all the entries are automatically created for me. My DVPro1, my DESBAR entries. I don't have to manually type these out. The web app is creating these for me. We also have a requirement that says 2 of the design variables are related to each other. So I'll go ahead and say that design variable 3 will derive the value of design variable x1. And here on the right, you see that the necessary D-link entry is created for me. Again, you don't have to write these statements all by hand. The web app automatically creates it for you. After we're done creating our design variables, we'll go ahead and create our design objective. Here, I want to set the weight as my objective, so I'll select it. Of course, I want to minimize it, and that's how simple it is to create your objective. Once again, here on the right, I have the necessary DREST1 entry created automatically for me. Now let's go ahead and create our constraints. We want to create 2 constraints in our design model. The first constraint is a displacement constraint. So here in this list, I'll simply select displacement, which creates a new displacement constraint here. I can then configure it and say that I want to constrain the X and Y direction, which would be the T1 and T2 direction. I can say this is being applied to node 4, and the range of allowed values is -0.2 and 0.2. And we also have to impose a stress constraint. So for this, I'll select stress. And here I can configure this to apply to the PROT property types. And this is being applied to properties 11, 12, and 13. And I want to select the actual stress as a specific quantity to constrain. So I'll select that. And then for the lower bound, that would be 15,000. And for the upper bound, that would be 20,000. And you'll notice that as you use the web app, you get these messages that indicate that there is an issue with the input. And once you know what the issue is, you can go ahead and resolve that and save yourself trouble down the line. Here we are with the statements that have been created for constraint groups, or rather our constraints. Let's go ahead and create a constraint group that contains all of the constraints we've created so far. And we will apply these to all the subcases. This particular model has 2 load cases, and we're saying let's apply all the constraints to all the load cases. Then in our exporter, we see the conversion happen. Our solution 101 file has been updated, so it's solution 200. There is an analysis statement for statics optimization. There is a pointer for the objective. There's a pointer for the D-sub objective. And there are a few other items that have been updated here. Again, the web app helps you convert your model to solution 200. Here on the right are all the statements for my design model. Statements for the design variables, the objective, and the constraints. And now what I can do is download local copies of these BDF files. So download BDF and the second BDF. And now I can perform my optimization. So let's go ahead and do that. So we'll navigate to my downloads directory and perform the optimization. And then one thing we always want to do is inspect the F06 file and make sure that the very bottom says run terminated due to hard conversions. It's an indication that the optimization went through successfully. So let me go ahead and inspect that. And here we see the successful message run terminated due to hard convergence. You can view your Excel data here, or rather your optimization data. I've already gone ahead and done this so we can view what our results are. Here for the objective, we can see we started off with the mass of 6.9 and we ended at a new mass of 5.47. So we were able to minimize the weight of the structure. Here we have the two areas that were set as design variables. One of the areas originally started at 0.15. The other area started at 0.1. And we ended at new areas of 0.1127 and 0.0839. And so that's the end of this walkthrough. The one thing I wanted to highlight is how simple it is to use the NASTRAN Solution 200 web app to convert your Solution 100 BDF files to Solution 200. It helps you create your design variables, your objective, and your constraints, as you saw me detail throughout the video. If you have any questions, comments, I'm definitely here to address those. Feel free to send me an email. I'll definitely get back to you. Thank you for watching.